Everyone, welcome to PROPL 2026. PROPL stands for Programming for the Planet. I'm Cyrus, and I'm listing the co-organizers of PROPL. Anil couldn't be here today, but he's planning to join this afternoon remotely and serve as sort of our scribe. I'll talk a little bit about the logistics of our living document in a little bit. Dominic's here and helps a lot with the organization. Thanks, Dominic. And Casey, I believe, is not here either, right? I think so. Yeah, so, but also helped organize the workshop. So thank you all for coming. This is a little bit different from a normal workshop at a conference like PLDI. We're very motivated by a particular problem that's sort of outside the traditional computer science set of problems. It's the problem of planetary health. And in fact, this is a crisis problem, right? This is a problem that's sort of acute and getting worse every year. If you look at this warming stripes visualization, I think this is a really nice way to sort of see the progression of the temperature, the Earth's temperature over time. This one ends in 2022. You can see it's already getting very, very red. If you look at the last 3 years, these are actually hotter than all of these. So the last 3 years were the 3 hottest years on record. And previous versions of this slide, maybe last year even, would have said 420 parts per million. It's now exceeded 430 parts per million at the Mauna Loa Observatory for the first time this year in 2026. Okay, so this is pretty bad, and probably don't need to convince anyone in the room, but this is largely due to kind of the industrial actions of humans. So if you kind of model just the natural solar and volcanic changes that would occur in green there, those are kind of flat relative to what's observed. So this alone is a crisis, but let me kind of put some underline this point a little bit more. This has an impact on all creatures on the planet. So there's a massive biodiversity loss that's occurring right now. If you look at the WWF's Living Planet Index there on the right, you can see this catastrophic decrease in monitored wildlife population. So the Living Planet Index is basically if you take a baseline in the 70s of species populations in various places, average them out, and you keep looking at that data, it's down 73%. Okay, so catastrophic loss of biodiversity. There's also a catastrophic danger to about 1 million species that are threatened with extinction and a number of others that are threatened with massive loss of habitat and other things like that. This has an impact on one particular animal that we care a lot about, the human. I just picked a few impactful things that are going on. If you look at water services, this is actually something that's improved in recent years, but is still in crisis, sort of access to safe and well-managed drinking services. It varies, as you can see, a lot by country. But the impact of this is that 1 in 4 people, 2.1 billion people on the Earth today, lack safely managed drinking water. And climate change is going to intensify things like droughts and floods that could potentially make that worse. Okay, so if you work in these areas, if you're the kind of person that produces graphs like this, you have to you sit with these kind of catastrophic numbers and you come to work every day because you're motivated by doing the work to make this better. And so I think all of us at some point have had this thought of like, what can we do about this? And I want to frame this as kind of a question of a collaboration or coordination. It's a massive group of people on Earth that care about these issues. It's not everyone, unfortunately. And in fact, there are people that are kind of like opposed to doing anything about these issues. And that can be a bit deflating. At least for me, it's very deflating sometimes. But if you just take all of the people that do care about these issues, it's billions of people, a massive group of people that could collaborate and do something about this. We don't need to convince everyone. But we do need to convince ourselves of what we need to do. We need to figure out what we need to do. And so, I'm not going to say anything that is particularly surprising here, but there is a lot that we can do. I'm going to start kind of big picture and then zoom into what we can do as computer scientists and computationally literate scientists in this space. So, big picture, we need to work to understand the dynamics of all of these interconnected planetary systems. So roughly gather a lot of data and use it to develop and refine models so we really know what's going on, so we can understand, for example, the scale of biodiversity loss both globally and in individual places. And then using these models and using these data and doing hypothetical reasoning, we want to, so the first bullet point is basically do science, okay? The second bullet point is do policy, right? So propose and analyze potential interventions that might help with this crisis in various ways. This requires doing this sort of hypothetical reasoning about potential interventions, informed by the first set of works. And then finally, we need to create kind of these conscientious social movements and organizations, or modify our current organizations that do all the human work that needs to happen here. So that coordinate all the different stakeholders that are all over the world, that are in all sorts of different areas, including the press, including the broader public, to create the necessary support to actually initiate these proposed interventions. The proposal actually needs to be effectuated at some point. And then it's not just enough to initiate, you have to manage and execute these interventions effectively. And then there's a lot of room for supporting roles here. So to support all of these activities, and think of yourself as part of this ongoing planet-scale collaboration, right? I think that's actually where a lot of us are going to end up sitting, right? We're not maybe scientists working on modeling water, but we want to support people that do. I'll come back to that. So this is a race that we are losing, but it is a race that we can win. That's what the Secretary General of the UN, Guterres, said. And I think with the help of computer science is what the attendees of PROPL' can do. All right. This book, 5 Times Faster, sort of also underlines this, that as you can see with the tagline up there, pace is truly what matters in the climate fight, that it's really, this isn't something we can punt to the next generation, or really even punt to the next decade. We need to be working now to address these crises. An extinct species doesn't come back. So some quotes from this book. Still, our appreciation of the risks of climate change is limited by the way our academic institutions encourage each researcher to focus on their own narrow area of expertise. You can think of this as a critique, but it's also, it's just an observation about many of our realities. And then any actor should understand their points of leverage. We each have to understand the opportunities presented by our place in the system and do our best to exploit them. Okay, so we might, this sort of narrowness of expertise can also be a place for us to think about, stop being overwhelmed by the big problem and think about our individual place within this big collaboration that we're doing. Okay, so coming back to this list of things that we can do, I want to reflect on some of the past workshops a little bit, which have really touched on aspects of all of this. So PROPL' is a fairly recent workshop. It started in 2024 at POPL. The fun naming, I guess, is a little less fun as we move to different conferences, but it's still fun. So PROPL' 2024, I think, was very interesting. It brought together a lot of practitioners that told us about the way they are doing modeling and analysis, the way they're building tools for one another. We talked about various particular areas like energy and efficiency. And then we had a lot of discussion about software engineering practice and software engineering ecosystems and tools, and both the state of the practice and potential future directions. And there was discussion about things like policy and decision making in our roles in those kinds of processes as well. So I encourage you to go back to PROPL' 2024. I believe there are YouTube videos of many of the talks, and there's material online. This is no less relevant, all these things are no less relevant today than they were 2 years ago, arguably more relevant than they were 2 years ago. And then we've been shifting PROPL' around to other SIGPlan venues. So we had PROPL' 2025 at Splash, ICFP Splash last year in Singapore. That was a very big event because of the co-location, so there was a lot of engagement there as well. There was a little bit more kind of focusing on the programming part of programming for the planets, but lots of interactions with practitioners and domains of practice there as well. Programming for biodiversity was a big focus. What are the principled ways to do scientific programming, which was a big bridge into our community. And then lots and lots, I mean, throughout all of this, there's been so many great talks and exciting demos and concrete applications that we've been able to enjoy. There was a poster session. We also did a proceedings last year. So there are some published papers out there that you can read in addition to the talks and other material. This year we're going to go in a little bit of a more narrowed and focused direction. After discussion with the other folks organizing, we thought it would be good to focus on this kind of last bullet point, because it kind of encompasses the others. How do we, as researchers in a community like the PLDI community more broadly, or the SIGPlan community or the systems and software community, support all of the above activities with this viewpoint of thinking of this as an ongoing planet-scale collaboration? And so today we're going to have kind of two sessions. We have this morning session, and then we have a more open-ended afternoon session. In the morning session, we're going to have 4 position papers that talk about the sort of the computational fabric, the infrastructure of the planetary compute engine that might drive future work, the sort of coordinating activity of all these different kinds of computation that's happening. I'll talk a little bit more about that. And so I'll let all these speakers speak for themselves in the next couple of hours. And then the second session is going to be a kind of a guided design discussion. And I'll talk about that in a second. I want to motivate a little bit of like what we're doing this time, because it's kind of grounded in some of the stuff that we talked about over the last 2 PROPLs. So I'm going to take advantage of the fact that I'm up here to show you some of my slides from last time, slightly modified. So these workflows that all of these people engaging in all of those activities are doing, they're these sort of loosely coordinated large-scale collaborations. This isn't the sort of thing where we're all having a group meeting and coming to a decision and there's one leader, right? These are distributed collaborations. And so we need to identify kind of best practices and permeate these through the community in order to make these collaborations effective. You're sort of collaborating with people you don't know, collaborating with future people, collaborating with people that are in completely different kind of communities than what you're used to. And so there's been a lot of thought in the community around large-scale collaboration, large-scale science. Open science was the big catchphrase for many years. And so some of the criteria that have come out of those discussions have been published in various papers. I like these criteria, the FAIR criteria, but there are lots of papers in this space. But let me kind of center our discussion on the FAIR criteria. I think this gives us a nice vocabulary for talking about design discussion. So the FAIR criteria it stands for findability, accessibility, interoperability, and reusability. I'm also throwing another R in there in the spirit of reading, writing, and arithmetic, reproducibility. Okay, so what are these briefly? Findability. So these are criteria about kind of like the artifacts that we produce in the course of scientific workflows. I use the phrase data in code here, but I guess you can include other scientific artifacts in this as well. So findability, data in code should be discoverable by people and machines. This isn't always the case. In fact, in many cases, when you're doing scientific work, your data and code is on your workstation, not findable by anyone, right? So these things don't happen for free, and I'll talk about that. Accessibility, kind of related to findability, but it's once you've found something, you have to actually be able to access it, and this requires thinking about who's accessing it, what abilities that they have, and kind of what form it has. Is it accessible? Is it a 10 terabyte data set? Is it a 100 terabyte data set? Oh, maybe that's not going to fit on a laptop. Then you have to provide some way to access it in a more incremental way, right? So those are the kinds of concerns that come up, especially as kind of science scales to this planetary scale that we care about in this field. Interoperability, very familiar word in a community like PLDI. Code should interoperate with different data sources, with different tools, with other code. And as we know, there's not a single programming language or standard in many of these cases, and so you need this sort of open-ended interoperability and kind of a focus on this in order to make it possible to build these large-scale collaborations with people that have many different skills and tools. And then the R, reusability and reproducibility, it should be possible once something is produced to run it, modify it, build upon it, and the reproducibility angle is not just once in the moment that it happened, but repeatedly. So you can't be sort of contingent on the current state of a database about the world in order to reproduce results. So you need maybe things like versioning and controlling dependencies and various other things. So we'll get into all of these specifics as we talk today. And then I threw in this additional one. Some of you might know that I work in live programming as my main gig. But I think this is actually quite relevant in science, because liveness is all about sort of things changing as you work with them. And in a field like planetary science, of course, the planet is changing continuously because it's a dynamical system. And our information about the planet is kind of like changing continuously. I was about to say increasing monotonically, but sometimes things like disappear off the internet if a certain government has its way, right? So we have to think about those kinds of things. So liveness, right? We can't just have something be kind of a frozen snapshot forever, although that's important for reproducibility. We also need to be able to update our view of the world as it changes, and it's changing very rapidly due to human action. And so I hinted at this, but I think a core problem we should be thinking about here is bad defaults. This sort of patchwork of software tools we use to do scientific work today is, like, broadly construed, requires putting in a lot of extra work to follow these best practices. This is something that you do, like, you write your paper, you do it in kind of the hacky way, and then you, like, if you really are conscientious about these things, you might go and spend another day trying to ensure these other things are there. And I think some of that might be necessary, but I think if the tools had better defaults, where like through the course of your normal work, without having to think about it, some of these things happened by default, I think that could solve a lot of problems. And that's an observation from design more generally. That's not just an observation in this field. It's, people kind of follow the defaults, and it takes a lot of mental energy to like deviate from a default. So if we design defaults really well, I think that can be really important. That was my point there. So, for example, consider computational notebooks. A lot of scientific work goes into computational notebooks like Jupyter, and these are very powerful and effective tools. They support, interleaving code and things like visualizations and prose. So there's a lot to like about computational notebooks. But if you evaluate their design according to these criteria, you get you sort of see that they're suboptimal, that we could maybe do a lot better. So let me just kind of outline this. Findability, right? A computational notebook, your notebook is living on your notebook server, which is often your workstation or your lab's workstation or something like that. And so it's not really discoverable by anyone else by default. And it takes a lot of effort to kind of make it public and kind of turn it into something that other people could find. And so if you're taking a data set and cleaning it up and analyzing it in a certain way, someone else might end up doing the same thing because they just don't know that you did that. They don't have access to your code, or there's too much and they can't find the exact thing that they need for the thing that they're doing. So findability, I think, is very poor in the current state of practice. Accessibility, I think it's kind of related to findability in this sense, but in this setting, but data and code should be retrievable in an accessible form. There's lots of stuff that isn't retrievable in a computational notebook, like the order of execution of cells, for example. There's also a lot of traditional accessibility issues with notebooks, like a visualization is not really something that someone with visual impairment can see. And there's actually people working on that, visualizations for people with visual impairment. Very interesting area, I think. So lots of questions around accessibility. The form of a notebook is also this sort of JSON blob that has not a lot of computational structure in it. Interoperability, this is really bad in a computational notebook, right? You have a notebook with a bunch of code in it. Other notebooks have no access to one another. You can do, there's like a library import you can do in Python where you execute another notebook in your current notebook, But if all you needed is one routine in that notebook, you've suddenly loaded this entire other data set into your state and then thrown it away because you're just calling one function with different data, right? And so interoperability, even if you just think about working within Jupyter notebooks, within Python, right, it's still bad. And then you think about the bigger interoperability problem of people are using different languages, not everyone's using notebooks, et cetera, right? So that could be improved a lot. And then reusability and reproducibility, I think, also connected to interoperability here, but it's not easy to rerun, right? You have no log of what was actually run to produce the notebook state because it's a out of order thing, and there's a heap that is separate from the actual state of the editable artifact. Modifying and building upon these things is largely through copy and paste. In fact, there's some data out there that says it's like 70% of scientific code is copied and pasted from other code. 70%, right? Okay. And then liveness, right? These things are not live, right? If the upstream data changes, that notebook is not going to re-execute or show you anything new. You have to explicitly go and do that. Sometimes that's what you want. Other times it'd be nice if there was a nicer interface to data that's updating constantly. If you have a satellite taking photos every day, maybe it'd be nice if your current, you had some way in a notebook to get the current state and also snapshot states of the past. And so last year, the talk that I gave proposed this system. This is a completely hypothetical system at the moment. And so I'm not sort of like plugging a thing that there's not like a GitHub Fairground repo or anything like this. This is just, it's nice to give a thing that we're building a name. And the design of this is really up to all of us. But roughly what we envision is something more collaborative and fair and live. That's still kind of based on some of these ideas. We're not going to completely change the way everyone works, but we want maybe a computational notebook system that operates more like a digital commons. And not just a regular digital commons, but a computational commons, one where thousands of these scientific artifacts, data sets, notebooks, plots, sensor configurations, et cetera, are authored and collected and maintained, not on our individual workstations or in our labs, but collaboratively in this kind of bigger collaboration that we're a part of in an executable and interoperable form, more generally in a manner that is fair and live by default, that kind of engages with this design principle of good defaults. So this is inspired by other digital commons that have been very successful, right? Think about Wikipedia. This is a big digital commons that a lot of people have contributed to, that has improved humanity in a lot of ways. You can also think of GitHub as a big digital commons, or NPM, or these big Linux package managers. These are all digital commons. These are things that people collaboratively contribute to for the benefit of everyone contributing to and using these commons. The thing I want to point out here is that these are largely file systems. These are all file systems, right? Wikipedia is a big file system for whatever the wiki markup language is. GitHub's a big file, literally a big version file system, right? NPM, all these things. What's not kind of inherent in the design of these things is computation. It leaves computation to the client of the commons. You get an artifact from these things and you run it locally. The thing that I think is worth thinking about is integrating computation more fundamentally into our digital commons. So the way I like to think about it, this may or may not resonate with you, but it resonates with me. If you think of something like Wikipedia or GitHub, instead of it being a big database or file system, as a massive live program that's executing and being collaboratively edited at the same time by thousands of contributors. These could be humans. These can also now, of course, we have swarms of AIs that are doing things, right? And we can discuss the design of that particular group of editors. But what if we had a big, massive live program? Well, if it's a big, massive live program, there's a lot that we can do. We can do things like findability could be find all uses of this data set, right? Find all uses is kind of a semantic operation. It's not a text search. You could do things like refactoring across the giant monorepo of all of climate science. In fact, if you haven't heard the phrase monorepo, right? If you go and work at big tech companies like Google or Jane Street or other things, they put all of their code into one big giant version control system. That's a that's a digital commons within their organization. Why do they do that? So they can do things like find all uses and do refactorings and keep everything up to date with the current state of the data that they have that they're working with, et cetera, right? And so I think we can actually learn something from these big organizations. They have some different design constraints, right? They have kind of more centralized leadership and things like that. But I think some of these things are maybe relevant even to these more distributed collaborations that we do in science. Okay, so anyway, some more stuff that we did. So Alexander, who's here at PROPL 2024, we started thinking about this problem back then, and we started thinking about it from the user-centered perspective. So we proposed this sort of user experience. We think it's important to have computational notebooks, but also have kind of other authored artifacts, things that like journalists and policymakers and so on can also interface with. So more of a kind of authoring document editing environment where you can drop into the code backing different things. This was our prototype where you have kind of a table and a map, but these things are all code underneath, and you can kind of like dig in and see the code and then work with sliders to change parameters in the code and so on. So since PROPL 2024, we've like built a bunch of this stuff. Ask Alex or me for a demo during the week. At PROPL 2025, a lot of the discussion in my talk started to discuss things around languages and systems, right? If it's a single massive live program, well, what language is that program written in? And of course, the answer that we came to at PROPL 25 was Fortran. No, okay. I mean, that could be an answer, but really the answer isn't any one language, right? The scientific code is written in many different languages by many different communities, and we can't actually force everyone to switch to one language. And instead, let's do that XKCD thing of like, well, let's come up with another language that serves as an orchestration language and design it so that it really makes working across all of these different things more suitable, more practical. And so that turns into a language design question, which is very relevant to PLDI. And so if we're going to design this orchestration language, what are the design criteria? Well, I think if we're going to motivate it by these criteria, we can kind of use this as the starting point. So if we're going to support findability, we have a giant, massive live program. You can't just do Command F and VS Code, right? You need things like indices and querying over this. To support accessibility, you need things like thinking about access control, the computational resources. Where does the compute actually happen? Is it co-located with the user that's actually working with a particular artifact? Is it co-located with data that it's accessing? Data format design and kind of protocols around standardizing data formats. Lots of UI design questions around accessibility. To support interoperability, that's really an orchestration language needs fundamentally support interoperability. So there's lots of interesting research questions around what a good foreign function interface could look like. I think that's a topic that many languages have FFIs, but there hasn't been enough research on FFIs, I think. I think there's lots of designs that haven't been explored yet. You're not just interfacing with foreign functions, you're also interfacing with foreign databases that live elsewhere. And how do you interface with that in a way that integrates with the semantics? And then many of us in this community, I think, are big fans of type systems as ways of mediating the interfaces between components in a system. What is the type system of this orchestration language, and how does that interact with the type systems or lack thereof of other languages that are being used? To support reproducibility and liveness, we need to do things like control dependencies and side effects. If you just have uncontrolled side effects, reproducibility is almost impossible. Liveness is almost impossible. You don't want, on every edit for it to kind of hit your database and download 10 gigabytes, and then you change one character and it does it again, right? So like you have to control side effects. And then to do this all at scale, you need, it's kind of the bread and butter of a lot of PL research. There's still a lot of open problems there. Incrementality. If you make a small change, you don't want to rerun everything in the commons. Parallelism, right? You can't sequentialize everything in the commons. There's not a sequential order of all scientific artifacts. It has to be inherently parallel. It has to be distributed. There's not all running on one machine. There can't be any gaps in execution, right? If I like make a mistake somewhere when I'm editing something in the commons and I commit it, or I go and get a cup of coffee, I can't have that bring down everything the way a traditional type checker in a programming language would, right? And so lots of interesting questions related to liveness at scale. So this is very big thinking, right? Like, what if we designed a massive live program and solved all these problems? I think this is the right time to do this kind of big thinking. This would be kind of pie in the sky stuff maybe a decade ago, because, well, then somebody would have to like take all the resources, all the things everyone has built over the last many decades and kind of incorporate them into this new system. But now we have this opportunity, I think, some of you might disagree, for kind of ingesting things more quickly, right? As we solve these PL and systems and HCI problems, as we build the system that should exist, the adoption cost structure has changed a lot because the kind of costly and boring work of integrating prior stuff that people have built into this system, you know, like taking a library and building bindings for it in a new FFI. Who wants to sit around and do that? Well, you know, maybe an AI really loves doing that. Or at least can be convinced to. Maybe not, right? This is an empirical question. There's also a question of sort of like what values do we have as a community about AI, but I think it's worth considering this at least. And then of course there's lots of socio-technical questions beyond this, right? This is meant to be something lots of people contribute to. What incentive structures exist for contributing, right? We should maybe design those in the same way we design the system itself. There's going to be some level of training. How do we build scalable training? How do we actually get this in the hands of people? Or maybe not scalable training. How do we give something to a PI that they can give to their students and feel ownership over? Shared governance, right? This is a big system. It's going to be governed by, you know, similarly to like Wikipedia. There's going to be governance and rules and like sort of what are the procedures for that. This is going to cost money to build and to sustain development. What are the funding sources for this kind of thing? And this is not going to all like come out of our heads today in one Google Doc later this afternoon, right? This is going to require participatory design iteration. Participatory meaning with the people that are going to use this. Some of them are here today. Almost all of them are not, right? So we need to get ourselves out into their world, look at their problems, and try to solve them using tools that we think maybe are better, and we'll probably learn that they're not better, and then we'll iterate. And at some point, maybe they'll become better, or we'll learn something really important and write papers about scientific programming practice and how they're actually doing it in a way that like surfaces problems that we haven't considered. And then the benefit of all of this stuff should be kind of broadly distributed. It should be equitable, right? We're not from those countries. Most of us are not from those countries where the map earlier showed a lot of water scarcity, for example. But we're trying to help. We should engage with those people. We should make sure that we're not sort of the benefits of this system are not just going to the places that don't need them the most. Okay, so I'll stop there. This is what, you know, this is one framing. I think it's useful to have a concrete framing just rather than to have an open-ended discussion about all of programming in the planet. I think it's ripe to do a kind of design discussion like this. But if you think I'm missing something or that we need to think about something that's just not been brought up at all, this afternoon is your opportunity to do that. So it's going to be a series of guided discussions. Roughly, it's going to look like a 30-minute session-ish for each of these topics. User experience. I think grounding everything in like what will this feel like as a scientist to work in is really important. So that's where we start. And then things about like the programming model and interoperability and scaling and AI stuff, socio-technical stuff. I'll give a very brief reminder of kind of some of the big problems before we start each of these sessions, just a minute or two, and then we will discuss. The way we're going to do the discussion is we have this living document. I'll leave this up for a little bit if you want to scan the QR code or type in the link. You can. It's just a Google Doc. Once I see everyone's cameras down, I'll open it up. So this is really meant to be just a space for you and also Anil later will be our scribe to to take notes, to ask questions that you want brought up, to make comments, to point people to things that you think might be relevant that maybe not everyone knows, right? If there's a great paper about this that is worth checking out, leave a link to it. I want to encourage everyone to contribute to this, not just the senior folks. If you're new to this community and you have what feel like naive thoughts, naive questions, great. Right? That's really important knowledge for everyone. Like, what are the things that are confusing and what's on your mind, right? I think that fresh perspective is often quite valuable. So please contribute to this. I'm going to use the document as the place to kind of like decide who maybe is going to start talking out loud. So sign your note or whatever if you want to be kind of called on. Yeah, and if you see anything, if there's anything logistically here that you think could be better or whatever, go for it. Also, if you want to like +1 things that you think are interesting, that would be great. It's just a Google Doc, so use it however you want. Okay, and then one last note here. We will have an informal workshop dinner this evening. We have a reservation at SALT at 7 p.m. That's at 1047 Pearl Street. If you want to coordinate on walking there together, 7 p.m. is a little bit after the end of today's events. So if you end up going back to your hotel, then you can just meet us there. But if you're still around here and you want to coordinate, maybe leave a note in the living document. There's a section at the end. Okay, that's not a formal workshop dinner. That's just we reserved a couple of tables there, kind of situation. Okay, so I think that's it. Let me actually just pull up this document and show you kind of what's in it. Where are we at on time? Okay, that's about right. Great. Okay, so this is the document. I'll try to get, in the break, I'll try to print out this QR code on a sheet of paper if you missed it. And if you want to leave any notes or comments on the introduction, you can do that here. And we have sections for each of the talks that are coming up. One thing I want to note is feel free to leave notes ahead of time. You don't need to wait for that session to start. If you're like, I want to bring up this in the AI discussion, or I want to bring up this in the interoperability discussion, and you want to take some time in a break and get your thoughts together and write something down, perfect, right? Let's do that. Other than that, consider signing your comments. We'll have a discussion towards the end here about what we actually want to do in terms of after this workshop with this document and as a community. Is this just for us, or should we create something more public? But that's it. Okay, thank you. Excited for a fun day.